Homens, do you want me there?
E vai ser preciso mais gente ali.
Yeah, it's better don't.
Agora não se leva, não está no ar. Devagar, devagar. Slowly. One step. Another step.
Manja ali. Pega a varinha de braço.
A mysterious-looking box arrives at the Ecton Mines in March 2022. This contains a new submersible robot of a type that made a first visit in 2019.
Now, the idea could be we go there, turn, and then from
This was part of a programme of field tests by a consortium from 7 countries, led by Professor Norbert Zizon of Miskolc University in Hungary. The submersible robots were developed by engineers at Tampere University in Finland and Inestec Robotics Laboratory in Portugal. Deep Ecton was selected as the most complex of 5 test locations around Europe. Copper ores have been mined at Ecton since the Bronze Age, peaking in the late 18th century with production that earned the Duke of Devonshire a fortune. The main deposit at Ecton was a near-vertical pipe containing very high-grade chalcopyrite and bornite copper ores, as well as lead and zinc ores. In the 18th century, miners went below river level, where they entered the mine using a series of ladders. There were also deep shafts for pumping and for lifting the ore from depth. Long horizontal levels then took the ore towards surface. One of these, 62 metres below river level, was part filled with water and used as an underground canal known as the boat level. The mine was relatively dry, but water still needed to be pumped out, and a cunningly designed water-powered pumping engine did all that was needed. But from the 1790s, the mine at depth became uneconomic, and eventually pumping was stopped in 1855. It took 4 or 5 years for the mine to flood to river level, but since then, what lies beneath the water has been a mystery. Since mining engineer Jeff Cox acquired Ecton Mine in the 1970s, the parts of the mine above water have been used as an educational resource. Although Jeff died in 2003, the education continued. The charitable Mine Management Trust, founded in his memory, was a participant in the EU-funded UNEXMIN and UNEXUP research projects between 2016 and 2022. Submersible robot dives were made at Ecton in 2019 and 2022. The robots and smaller remote-operated submersibles, known as ROVs, were deployed in the locations that we hoped would give access to flooded workings deep below the launch sites. The specially developed UX-1 robots carried 5 or sometimes 6 cameras and other instruments. A smaller commercial ROV that we also used had 1 forward-facing camera. We've been able to combine the camera views from some of the UX-1 footage into a single frame, as you can see here, with the front camera view in the middle and the left, right, top and bottom views arranged around it. But where you see just a single view, this is generally from the UX-1 front camera or from the ROV. On some of the sequences, there is also a lot of snow. This is silt and mineral flakes dislodged by the motion of the robots. Here is a plan of Deep Ecton level showing the main dive locations, the pipe workings, the pumping shaft and the winding shaft. We start now with exploration of the pumping shaft. This was the last major shaft at Ecton that went deep into the main mineralised zone. It was sunk from the Deep Ecton level, not from the hilltop, as water needed to be pumped only up to the river level. Many side passages were found as this was descended. At 26 metres depth below the water, there was a short passage that led southwards, linking directly with the winding shaft that was just 5 metres away. There appeared to be a small storage area here, also between the 2 shafts. Here at 26 metres depth in the winding shaft is the other end of the link passage. This window is too narrow even for the small ROV to enter. This small hole is most likely to have been created later than the rest to provide ventilation during sinking of the pumping shaft. From 50 to 58 metres depth in the pumping shaft, a much larger cavity was intersected on the north side of the shaft. This was an irregular, stope-like opening which had apparently been driven to extract a mass of ore. We also found some small openings from this, 3 at floor level and a small window in the wall on the east side. This is one of the openings at floor level that leads through to the main pipe workings. And here is the window, high in the east wall, that also links through to the pipe workings. And another passage continues from the northern end of the stope. This plan of the workings that we explored down to about 60 metres depth shows what we're looking at here. Another low opening, partly choked with rubble, direct from the shaft, trends eastwards and has been proved to link with the main pipe workings. Also, direct from the shaft, there was a small, narrow working trending a few metres southeastwards, towards the winding shaft, but it passed to one side without any link to the shaft or to the main pipe workings. And this shows the location of that dead end working. A short way below this in the pumping shaft, at 65 metres below the deep Ecton level, is an opening, mostly blocked by a well-built wall or dam. There's a build-up of sediment behind the wall which hides any possible passage beyond, but clearly the wall has a purpose. This could be either the side of a cistern used in a multiple lift pumping system, or more excitingly, it could be a passage leading to the southern end of the boat level. But whatever its purpose, it did not extend even a further 5 metres southwards to link with the winding shaft. Continuing ever deeper, A further opening was found at 80 metres depth. This was explored and was seen to link just to the winding shaft. Then from 90 to 98 metres depth, we could look into a large mined cavern on the east side of the shaft. As we move into this, we can see a steeply sloping rubble floor. As the submersible moves around, it becomes apparent that the cavern wraps around the shaft. Looking back at the shaft, it's clear that the miners left walls of rock around it, possibly to avoid damage to the ropes and the tubs bringing up ore from greater depth as the side working was being created. Here we can see the crest of the rubble slope, but we have no idea what lies beyond it. This is one of several prime targets for future exploration once a robot can be operated without a cable from the launch site that would easily get caught up. We're now returning to the shaft, which we can see in the up and down camera views. At 98 metres depth, to the left of the huge opening, is a smaller opening, with timbers in the roof showing that it may lead somewhere, also noted for future exploration. We're now continuing downwards, ever deeper, with the robot's front camera looking straight down the vertical shaft. At 123 metres depth, the robot could go no deeper, halted by broken rock across the whole width of the shaft. The shaft was originally very much deeper, but there was no way to clear this blockage, though it may be possible in future to bypass it by navigating through the pipe workings. The next launch site was in the winding shaft. This shaft sunk from the top of the hill, where a steam engine was installed in 1788, is just 5 metres south of the pumping shaft, and was even deeper, going to nearly the bottom of the workings at 282 metres below river level. Just 5 metres below the water surface, we found an opening on the north side of this shaft, which leads to a narrow level ending in a boulder choke, which may possibly connect with a choked opening at 8 metres depth in the pumping shaft. Its purpose is unknown. At 54 metres depth, there's a large window on the east side that opens into the cavernous pipe workings, so large that we can't even see the sides. We shall return to this huge chamber in a few more minutes. Just 4 metres below this, on the west side of the shaft, there's a circular artefact that appears to have been placed deliberately on fallen timbers, maybe as a warning not to enter a short passage behind it. It's actually directly opposite a passage which links to the pipe workings. And then below this, the shaft continues without any side openings at all, as far as the link to the pumping shaft at 80 metres depth that we saw earlier from the other end. Beyond this, descending ever deeper, at between 94 and 97 metres, there are connections on the east of the shaft into workings which may connect with those seen previously from the pumping shaft. At 99 to 101 metres depth, there's a broad open stope with timbers and stacked deads. We haven't established whether there's a possible link with the workings that were intersected by the pumping shaft just a few metres higher. Finally, at 114 metres, there's another impassable blockage. As in the pumping shaft, it may be possible to bypass this through the pipe workings, which haven't yet been explored. Submersible dives in the two shafts were fairly straightforward, but the pipe workings were a greater challenge, because it wasn't obvious that there was any route downwards beyond what little could be seen from the launch point. But on the east side of the pipe working, only a few metres below the water level, it was clear that there were several accessible, though small and irregular openings, leading to a veritable maze of workings. Reflecting the European character of the project, some of us started referring to this as the Swiss cheese zone. The openings didn't all lead downwards. This one came up to surface in an adjacent part-flooded side chamber from where explorers have long looked down onto these timbers. This is the view from the down camera during the first dive that did go downwards into the pipe workings. The submersible was steered through a network of openings until it came out into open water at 20 to 25 metres depth. The Swiss cheese zone above was interpreted as an area where irregular and discontinuous patches of ore had been mined. Below 21 metres depth, the roof and walls could barely be seen. While here at 34 metres depth, we could see the floor for the first time. the top of a rubble floor sloping steeply downwards to the north. The true scale of the workings can be seen in this scanning sonar image. The diameter of the robot in the middle is 60 centimetres, and the working is over 20 metres across. This plan view, summarising the workings found down to a depth of 60 metres, shows the full size of this part of the pipe workings as proved by 3D scanning sonar. There were reported to be even larger openings at depth, which we haven't yet been able to explore. A north-south section, using sonar data, shows a steeply sloping floor at the southern end. This shows a thick accumulation of rubble, and the floor at 60 metres probably extended along the whole length of the workings here. And a computer model, created from the 3D sonar data, shows the form of the workings as they are today. Eventually, looking up, the window to the winding shaft at 54 metres depth could be made out. Below a retaining wall, we can see the entrance to the short passage to the winding shaft at 58 metres depth, while the large cavern continued to the north. To explore the huge pipeworking cavern further, it was clearly going to be much simpler to dive in the winding shaft and then go through the window, rather than threading away through the Swiss cheese. After going through, we looked back at the window. Changing direction to go northwards after diving through the winding shaft, we were then able to explore the pipe workings further to the north. The floor here, although still covered with rubble, was flat. After another 15 metres we came to an end wall, but in the northeast corner there was a tall, stope-like slot continuing northwards, which we followed. We continued along this as far as we dared. It appeared to curve to the left, and again, this is a target for future exploration. At the base of the northwest wall of the large pipe workings, at a point further back, there were a series of openings to the left, which linked with the stope at the same level that we saw from the pumping shaft. And this is the small window that we last saw from the other side. Between the pipeworking and the stope, there was a further unsuspected straight passage trending northwards. After several metres, this passage led eventually to a rockfall, but could be seen to continue into darkness beyond. Together with the slot that had been found on the east side of the pipeworking, this has yet to be explored, but we postulate that the two are connected and could lead down to the next wide section of pipeworking. There was a final dive from the pipeworking launch platform using a small commercial ROV. We explored the western end of the pipe, just below river level, where stope-like workings extended westwards below the stope that was already known, above water level. At 14 metres depth, we found an iron chain in situ, spanning the stope between two cross-cut passages to the south and to the north. The northward passage ended after several metres at a winze of unknown depth, leading downwards. This confirmed we were in the ladderway shown on the 1858 elevation. With an independent submersible, this could be explored further. If this is open to the bottom, there's an underground boat level at 62 metres below the water. Do the canal boats and documented timber horse-drawn winding engine on a shaft leading to depth still exist? At present, we simply can't go there. Returning to the chain, the southward passage is directly opposite the northward passage and in line with it. The southward passage ended at the base of a shaft, with the remains of a ladder still in place. This lies within a small shaft known as the South Winze, coming down from the deep Ecton level, and again coinciding with the position of the stepped ladderway as indicated on the 1858 elevation. This was part of the miner's route into the lower parts of the mine. This shows the position of the chain, the ladder, and the next winze leading downwards. Part of a similar miner's ladderway is still in use today, above water, between deep Ecton level and Salts level that's 34 metres higher.
The original ladders, about half of them are original. Strictly speaking, they're the so-called new mine ladders that were put in 1860 on. So they're only 120 or 130 odd years old.
Finally, below the chain, which was probably one of two safety handrails for a timber bridge across the stope passage continued steeply downwards and turned right to open out into the top of the large pipe workings at 29 metres depth, proving yet another route into the main pipe workings. The robot and ROV dive missions from these two projects added greatly to our knowledge of the history and the geology of Ecton Mine. Although the shafts were blocked at only a third of their recorded total depth, there remain possible access routes to explore to greater depths. Here there were pipe working chambers that were even larger than the one that we've explored. These results were achieved by the collaborative efforts of the UNEXMIN and UNEXUP teams across Europe, and of the Ecton Mine Educational Trust, with funding from the European Commission and UK Research and Innovation.